This is the second example for zeros. We're given this polynomial, and we're given just a little glimpse of part of its graph. So this is not the graph of the whole thing, but we do know it goes through negative 3, 0. So we know we have one of the zeros. So my strategy then is to take that negative 3 out of it and then see what's left and find my zeros from there. Really what I'm doing is I'm factoring out an x plus 3. And what I'm left with is an x squared because x cubed divided by x is x squared. So I'm going to do that division now. I have 1x cubed, 11x squareds, 31 x's, and 21 ones. So when I do synthetic division, first thing I just bring down. Next piece is to multiply. So 1 times negative 3 is negative 3. Then you add 11 plus negative 3 is 8. Then you just keep doing this, multiply. So 8 times 3 is negative 3 is negative 24. So 31 minus 24, we're going to add those. 31 plus negative 24 is 7, sorry, positive 7. And then again you multiply, negative 3 times 7 is negative 21. Then you add 0, and that you will always get a remainder of 0 if that is really a 0 of it. So these are the coefficients for that. So I have 1x squared plus 8x plus 7. And what I could do is I could run this through quadratic formula, a is 1, b is 8, c is 7, but I actually noticed that this is factorable. In other words, things that multiply to 7 add to 8 are 7 and 1. So this factors to x plus 7 times x plus 1. And the way that I get zeros from that is I solve each of those equal to 0. So when is that 0? And when is that 0? So subtract 7 from both sides, x is negative 7. Subtract 0 from both sides, it's negative 1. So my zeros are, this one was given to me, negative 3, and then I found these two, negative 7 and negative 1.